this is the default view of the AWR report. That's the home page where you have the landing screen of the AWR report. So shows you a lot of information. First, it starts with the DB name, with the DB ID, with the instance name, and its startup time, and if it's a rack or not. And at the same time, it also provides you. I mean, if someone asks me like, what is the very first thing that you actually checks within the AWR report? So the very first thing that I always check is the elapsed time and the DB time, because using these two metrics, you will be able to understand like if the system is busy or not, right? Just give me a
Right.
second. Just give me a second, guys. Okay, I'm sorry, I'm back. Okay, so the very first thing that I actually check in an AWR report is always the DB time and the elapsed times, because that's how you'll be able to get the average number of active sessions. And that should be the very first thing you should also checks in an AWR report, right? So basically, you have to do a divide between your DB time and the elapsed time. For example, uh, in this particular, okay, let me divide first. 15.18 divide 2451.01. Okay, so it says, sorry. Mm. And then do a divide between 15. So it says 161 active sessions were there, right? So this is too much actually, right? And if someone asks me like what is a rule of thumb, like when exactly we should say, okay, this is high or this is low. So always treat the CPU count as a standard for comparing the average number of active session as a rule of thumb. Like in our case, how many CPUs we've got? We've got 32 CPU, right? And the average active session one is 161. That means at any given point of in time during that period of AWR report from 10:00 to 10:15, I mean within those 15 minutes of AWR report, around 161.46 sessions were there who were actively waiting on something, right? And considering like we have got 32 CPUs, so, I mean to say, like if AAS or average number of active session is higher than the number of the CPU, then there is a problem. But if this number is way too high than the number of your CPUs, then there is a choke point, or there's basically a breaking point in database, and you're really in a soup, and the you've got a big problem basically and need immediate attention or care, right? So same is the case with this database from which I've copied this AWR report, right? So this means the workload is very high, right? Around 161 sessions were found waiting on something. We are again not sure where exactly those sessions were waiting on, but yeah, 2451 minutes of DB time. When you actually divide it with the elapsed time, 15.18 minutes, then you basically gets the average number of active session or AAS, right? And when you do a comparison with number of CPU, then it's actually very high than the number of CPUs we have. So there is a definitely a very big problem going on. So let's assume we have got a different AWR from a different period of the same database, maybe one day before, right? Same day we have got this this average number of active session very less. It was hardly 10 average active sessions. So if you compare it with the CPU, of course, system is doing work, actively doing work, because 10 active sessions, 10 compared to 32 CPUs. I mean, a lot of CPUs are still free. That's what actually represents, right? But now, even after 15 more minutes, you are saying this number is though goes little down, gets little down. Now you're not getting 161 as the active sessions, but now you're getting 50. Still, there is a huge gap from the 32 CPU count. So that is why, I mean, always treat CPU underscore count uh, parameter as a rule of thumb in order to judge if the system is slow or if it's really slow, and what it is. Okay. Any questions about this?
So, sir, we can consider means this that if around 900 minutes of DB time is there, it is okay that all the CPUs are almost used in 15 minutes.
900 minutes? Where you saw 900 minutes?
No, no, I'm suspecting means we have 32 CPUs, huh?
Right.
And
Right.
if around I calculate with 15 minutes,
Mhm.
15 to 45 minutes, 450 minutes of work is there. So if the DB time is 450 minutes, I think that is fine.
Absolutely. Yes. Yes. As I told you, like CPU count is the benchmark, right? So whenever you have average number of active session that is less than the CPUs, or that is all good, right? But if this number is soaring, right, and continuously soaring and ascending, then of course there is a problem. And if not a problem at this point, but maybe in the future or very soon you'll hit a problem, right? So that's what I mean. It's a really important metric. And few other important things is like always collect multiple AWR reports, not only a single report you collect, right? And stick to a particular period of time, right? For example, if you have a problem that was happened for 20 minutes, do not come up with a 24-hour or a 48-hour long AWR report, because with that big AWR report, uh, most of your metrics will get averaged out, right? So if you have a problem that was there in the database for a very short period of time, hardly for a few minutes, do not generate AWR report for 8 hours or 24 hours or 48 hours. That doesn't make any sense, right? So then ultimately your figures, your metrics, your areas will be averaged out, right? So and you won't be able to catch the problem. So that is why, for example, you've got a 15-minute problem, generate a 15-minute AWR report. So but well, let's assume like the AWR retention in your database is 60 minutes, right? And you do not have now what you will do. But again, that is a there you cannot do anything, right? Because if that has happened in the past, so you cannot change it. You only have 1 hour snap interval, so you've got a 1 hour long AWR report. So if your problem was happened only for few fraction of minutes, few fraction of seconds, maybe, then again there is a huge chance of your stats will getting averaged out or getting normalized, right? So stick to a particular time. That's really important. And for example, you have a rack environment, so never ever, I will not say never ever, but yeah, you should basically generate instance wide AWR reports as well. I mean, for example, you've got two node rack, so generate two individual rack reports from both of those two instances, and at the same time generate a rack report using AWR grpt.sql, right? So you've got a rack report and you have to get your instance specific AWR reports as well, and then start your analysis, right? In fact, even if you go and raise any SR with Oracle customer support, they always ask to provide them, in case of a rack, provide them separate or individual instance wide AWR reports along with the rack report. Because if we talk about the rack report, a lot of sections you do not see, like segment statistics area, something you won't be able to catch there in the rack report. So that is why it's always good to have an individual report from each of the rack instance, right? Also, use Ash as much as possible, because nowadays, since the introduction of Ash in Oracle database, so it's really helpful nowadays to understand the system performance metrics using Ash, right? And for example, like at the moment you've got 1 hour of AWR retention, make it less, maybe 10 or 15 minutes. I know there is a limitation. You cannot go below 10 minutes with an AWR report, right? But make it 10 then at least if your system is really slow and getting frequent slowness issues or performance problems. So do not set it at to 60 minute of AWR retention. Make it at least 10, the least minimum, so that you've got uh, you know you got a good picture of the database for that particular moment. Any question?
No, sir.
Okay,
Also,
now uh, let's move. And before I move, I would also like to say, like, if you have seen the AWR reports, you see some of the units that are frequently used. S is basically used for second, CS is for centiseconds, and MS is for milliseconds, and US or mu second, sometime what we call is a microsecond representation. Okay. Whew. All right. So, what load profile then? Any question? No question. Okay. Now, what is the importance of this section called as the load profile? You see a lot of things here, these metric DB time, DB CPU, redo size, and everything, right? So it's important, like you pay your observation or your focus to the physical reads, physical write hard parts, right? And because though it actually contains a lot of other metrics, but those are really not that important, right? Because if someone asks me what are the most important thing that you observe, so I'll, like, in case if you have a database where the problem is huge amount of redo generations, what I can do, I'll go and generate the AWR report for a same period from a different day, a good day basically, where you do not have that problem, and then compare this particular stat, like what was the size of redo, this particular metric, redo bytes generated. So for example, here at this moment during those 15 minutes of this eight particular AWR report, it says 2367. Then I'll see and compare, like, what was the figure back then, those 15 minutes, 2 days back or one day back, right? If the number is really, really higher, then of course I need to uh, uh, drive my analysis or move it towards the the redo size based approach. Okay, accordingly, physical read, physical write, like how many disk reads happened and how many disk write happens, right? And read IO means how many times and per second, what amount of read IO requests happen. So 388.3 read requests on an average actually happened per second. Same is the case with other as well. So hard passes, SQL work area, logons, execute, rollback. Again, I mean, this actually contains a lot of other, lot of statistics, but again, uh, covering each and every and under, making a relation using each of the metric, it's not that easy. It takes a lot of time, right? So when you have a very urgent problem and you have to solve it as soon as possible, so pay attention to only few and vital ones.
sometimes I have a doubt. What should be the ideal value for the physical reads and the writes? So how
There is
can
no
we?
ideal value as far as physical read is concerned. So, for example, same day, uh, yesterday you've got physical read very less, but today you've got a lot of physical read. So again, it depends on the workload. For example, today you've got 5 new people join the team from the customer side, and they actually doing some testing at the moment. So that is why you are seeing a spike in the physical read. So because they are they are running a lot of select statement in your database, and they're reading a lot of big tables and doing a full table scan, right? So that's one of the scenarios. Not only full table scan, of course, that it could be a single block reads as well. I mean, from indexes as well. But again, if you're seeing a sharp spike in the physical read, that means the load has been changed and a lot of select statements started happening, and which is actually reading some stuff from your database. Okay. So no as such a benchmark. You have to set the benchmark by your own then.
Okay.
All right. Again, I do not pay much attention towards this instance efficiency percentage because it actually says soft parse and the hard latch hit ratio and the buffer hit. But these are pretty outdated method of doing the performance troubleshooting and optimization these days. But because usually we start with the event based or event driven analysis nowadays. So let's talk about soft parse, what exactly it is. Like for example, when you already have a parsed version of the SQL statement available in the library cache, and next time when the same SQL comes and hit the DB, so it actually need not to go through the expensive parsing phase, because the parsed version of that same statement is present, and it will simply go and utilize or reuse it. That's it, and you ultimately save a lot of efforts, uh, and your SQL will be fast and results will be good, right? But this sometime will be misleading. Why I'm saying misleading? Because few of the times, due to some AWR specific bugs, you might see like this number is going really low, like in 80s only. So again, you should not go and treat this metric as a benchmark. You should go and do the analysis by your own and then reach to that conclusion. Okay. Now, the very important area or a section of this AWR report is the top 10 foreground wait event by total wait time. Now, there are foreground and background wait events, right? So now, first of all, what exactly is a wait event? Can someone answer me? Shreya, would you like to answer what is this thing called as a wait event? What is a wait event?
Miss, for some reason, some query is waiting for some another transaction is going on in the database.
Absolutely correct. Yeah. So when, for example, I am the user and I just connected to the database and I've fired a SQL and I intentionally fired a full table scan. So what it will do, it will be, because that full table scan on that table is very, very huge, very big, very fat. So my session will now wait before I get the final output, right? So in within the database, my session, which has a unique SID allocated to it, and on the OS, I have got a unique PID allocated to my session. So what will happen basically? My session in the database, within the database, will be waiting on DB file scattered read event, because I'm actually doing a multi-block reads from the database until the time I get the result back to me through the server process. So my session will wait on that particular event. So that what the event represents. Correct. So foreground event is when you are doing, I mean, when the users are modifying anything. So that's basically part of the foreground. Background wait events are the events which are caused by the database specific background process. Like for LGWR log writer, we've got a log file sync, or DB file, or log file parallel write, log file parallel read, or CKPT specific error messages. Sorry, CKPT specific wait events, right? So background wait events are those events which are generated, or which are there due to some background processes and not by the user processes. So we should always focus on, of course, not always, of course, if you see there is a problem with the user IO, then of course you should start with the foreground events. But if you see user IO is okay, but the problem is with the system IO, right? Or maybe with some background processes, then you have to change your gear and then focus on the system IO specific part. Now, if we talk about this particular section, guys, any one of you would like to answer what is the biggest problem here and from where we should go and start our analysis? Any one of you?
Uh, I
Library,
think, sir, this
library कैसे?
Library cache? Why? I mean, any particular reason why you actually pick library cache only?
Yeah, actually, I've seen the weights are high actually. For weights events are high and also the concurrency is there.
Are you talking about this one?
Yeah,
This library cache mutex X or library
yeah.
cache lock?
No, I'm just talking for the mutex X.
Mutex X. Okay. Okay. By the way, you should never ever go and decide on the basis of number of weights. You should always go and decide on the basis of weight average MS. Like if you go and check, like though it seems like this the session goes through lot of library cache mutex X specific wait events, because 157208 times during those 15 minutes database sessions goes through this particular wait, and on an average they spend 97.75 ms for each time it waits, right? So but on the other hand, if you go and see 1024 and 1041, I mean these two are massive, right? And in fact this is also pretty huge, right? But at the same time, you should you should build the correlation basis on the weight average ms and the db time column. So though this weight average for nqtx allocate itl entry weight event is 1024.95, but at the same time it's contributing 36.5% of the total db time available, right? It's a configuration class weight event, so you should start focusing, and you should uh, move your analysis toward fixing this allocate ITL entry specific weight event first, right? Before you switch to other events. Because what happens is, like, these weight events are sometimes very interdependent, or are, are dependent weights basically. Like for example, if you fix allocate and allocate ITL entry problem, you might see some of the other weight events are now gone, or are reduced drastically, right? So you should very first check with the average weight, like how much time each session is spending on the database in order to get in order to get its data or resource or it, right? So on an average, every session spend around 1024.95 ms, and which actually contributes 936.5% of the total db. So this is huge, right? So I'll first start my analysis for the sessions which are waiting on nqtx allocate itl entry. Okay, the another one is the latch row cache object, right? Anyone would like to answer, like, what is this thing called latch? What it is?
It's a temporary lock.
It's a
It's a
temporary lock.
lock in not in a sequential manner. It whenever the someone is need a lock on a table, it will give.
Okay, let me help you. Talking about a latch or a pin or a mutexes, right? All of these things are relevant to the memory components, right? When it comes to your table and index level structure, it always happens on NQ, right? If you take a look, like we have got NQ TX, TX stands for transaction, NQ TX allocate ITL entry, right? So there is this NQ and then there is a latch. Latches means it's a happening on a row cache, right? So these are the basically kind of a low level locks or low level locking mechanism that is used to protect the memory based areas. Like we've got a dedicated latches for your shared pool, right? And you've got dedicated latch for your DB buffer cache, and the latches that actually protects the memory structure within the DB buffer cache called as latch cache buffer chains, right? So talking
Mm,
about the latch are the low level serialization or scheduling mechanism which is used to protect the shared data structure in the SGA, right? And on the other hand, if you compare it with the classic locks, they are called as NQ. Like on table, you always acquire NQ or a log. On a row, you acquire NQ. On an index, you acquire NQ, because those are the you know are the kind of a logical structures. Those are not there in the memory, correct? Those are there on the disk. So that's the difference between an NQ and a latch. Any doubt? Hello?
no, sir.
Okay. Right. And talking about, I mean, this is a really wide topic basically, and sometimes it confuses people as well. So there are a lot of notes available online. I think I urge you guys to go and read about it if you really want to read. And there is a book by Jonathan Lewis called as Cost Based Optimizer. And also there is another book called as, what was the name? Just a second. What's the name? Oracle Core Internals. Right. Oracle Core Internals. This book called as Cost Based Oracle Fundamentals, and this is another book called as Oracle Core Essential Internals by Jonathan Lewis. And Jonathan Lewis, so far, I mean, he's the best. If you talk about Oracle database performance tuning, advanced level of performance tuning, and talking about the internals, deep dive internals of database. So this book called as Oracle Core Essential Internals for DBAs and Developers. So this book will help you to understand these things in detail. Again, if you do not want to read a proper book, and you want something concise, so you can go and read some online posts about it or some Oracle official documentation about what is the difference between NQ and a latch and what exactly is a latch and what all kind of latches are there. As I told you, and I've given some examples, in order to protect row cache that is within your within your shared pool. So this particular latch called as row cache object latch is to protect the memory structure, the things that are present in that memory area, right? And same goes with the DB buffer cache. For example, in DB buffer cache, you will see cache buffer chains that basically protects the things that are there in that in the DB buffer cache. Okay, so now let's focus on the primary event that we have identified. So it says NQTX allocate ITL entry. So before we go and dig in deep, we need to understand what exactly is this. And we know what is NQ, right? That means something that is happening on either table or an index, right? So if it was latch, then of course, uh, you know, it actually it will represent like things are not good there in the memory or in the SG or in the library cache or in the pool or shared pool, right? But now we're seeing this event is showing NQ TX allocate ITL entry. So what it means, it's a it's a proper lock or an NQ that has happened either on table or an index. But next thing what it says TX means TX stands for transaction. I mean, something that is related to the transaction is actually happening. And then it's allocate ITL entry. Now we need, I need to explain you about what exactly is the ITL. What is this thing called? ITL is called as an interested transaction list. Just a second. I need to take help of screenshot. ITL. Okay, now if you are familiar with the data block, like the architecture or the structure of a data block, that's how it actually created. So the first part of the block at the very top, there is a fixed area or the fixed header, what we call, and then comes, which is you are seeing right now in green color, is the variable size header, right? And the next comes is the Oracle data content space, right? And that's where the real rows were saved or housed, right? So in this particular variable header area, there is this thing called as interested transaction list that actually exists. Let me show you this structure. This is it. Like this is the header, which is fixed header. And in the variable header, you've got ITL slots, right? So for example, I am a session and I want to modify or I want to read something, right? And so using Oracle database smart or the intelligence, I reach to a point, okay, this is the block number is 1000, and within this 1000, I have the required or the requested or desired blocks available or desired rows available, right? So now I got the block address, so I directly reach to this block. But before I go and modify or read anything from a block, I need to acquire an ITL slot. Basically, once my session, just take a look at my pointer. So once my session comes and hit this block, first it will query the header if I am connected with the right block or not, if the information of that row is present in this particular block or not. If it says yes, it's there, right? And then it moves the request to acquire an exclusive lock in an ITL slot, right? So then after acquiring an ITL slot, it will point you to that respective record which you want to read from the block, or which if you want to modify it. For example, I've got a slot free, right? And then automatically I reaches to record one, and record one has a value of 40. So that record is now will be moved to DB buffer cache for manipulation, for data change, whatever, right? And once the modification is happened, then DBWR will write the dirty block into the disk, and then this block will be freshed, right? And you'll see a new record available here, right? So that's how the internal operations happen when you request it for a block in order to modify it to in order to query any block to read the particular row. So assume, because this every block has a limited number of ITL slots, right? So that means, let's assume this block has only 2 slots available, right? So I am the first session, this is the first session, and then it acquires, or uh, an NQ on this ITL slot 1, and then it connects with the required record, and then it fetches it and then move it into the buffer cache. But what happens before it moves to the buffer cache? It actually, there another session comes, session 2, and then again it want to read record 2. Again, session 2 also need to acquire a NQ or a lock in order to read the data from this block. So it will acquire that ITL slot, and then it is now authorized to process or do whatever he want to do with the block. Now imagine a situation when you got a session 3 coming and asking for a free slot, but there is a problem. Both of these 2 slots are busy. I mean, they're not yet free, right? So what it will do, your session will now wait on this event called as NQ TX allocate ITL entry. So it says the session, the particular session, it's trying to do a transaction on an index block, for example, right? And by the way, ITL is present both on table and on index. So you have to identify if it's happening on an index or a table, because um, otherwise you won't be able to catch the real culprit here. So NQTX allocate ITL entry. So ITL stands for interested transaction list. It's basically contains the several slots for the transaction, and when a row is in the block is locked for the very first time, the transaction places a lock in one of the slot with the row ID of the row that is has been locked, right? So that's why it's called as an interested transaction list. So uh, there is this thing called as init trans and max trans. Let me show you. If you go and scroll up, you'll see init trans and max trans. Init trans and max trans is basically, the initial transaction slot and the maximum transaction slots, right? So let's check. Init. Sorry, I've queried index or what? Yeah, DB indexes. Index DBA. Just give me a second. I need from the server owner equals to. Just give me a second. Let me connect with this input. Now, if you see the initial transaction slot is 2, right? So any trans, I mean, basically, for example, if you set it or specify 10, then 10 ITL slots are created on the block. And that actually guarantees the slot for 10 transactions. And the moment the 11th transaction will need to extend the ITL list or await, if that's not possible, that the, then you'll face the problem, right? As simple as that. Okay. So
So
yeah, the
we have to increase the init trans value in case
absolutely. Yes,
when the
yes.
table is most hit.
Absolutely correct. Yes. So what you will do in that particular case when you are facing in NQTX allocate ITL entry, you need to go to segment section, segment statistics. Oh, I know the problem. Segment statistics. Okay. Let's go to the segment by ITL weights. Now, if you go and check this, all of the most of the weights are actually happening on the indexes. In fact, all of the weights are happening on the indexes. No, there are a few on tables as well. Yeah. Index PK TRN subscription B. This index is responsible for 43.42% of the total ITL weight. And same is the case with the PK TRN DNA SE Optimi, again, a kind of an index. So what I did in that particular scenario, I actually increased the initial transaction list. And soon after modifying that, the issue was completely free. I mean, the system was totally okay. Right. And there are other ways as well, like if you basically keep the less space for the data, I mean, if you make sure that you have got less data inside a data block to allow the ITL sufficient free space, then you can do it by several ways, by setting a high value of the PCT free, right? And you can also do by minimizing records per block clause, right? So these are also a few of the alternates. But yeah, if you want a quick solution, what you can do, you need to alter the index and set the value of init trans and max trans, basically init trans, to set up the number higher so that you'll get more number of ITL slots free. Correct? So
So any demerit for this means we can set this high for all the tables then.
no. Again, it's there is no point of making it very high, right? Because ultimately you are increasing, you're bringing a hot block scenario if you do it on every other block, right? So in order to avoid that, only when you're facing ITL specific problem, then only go and change the initial transaction list size by using any trans parameter, right?
Okay.
Sir, the unit trans is suppose 2. So how much we have to increase? How can we identify that?
Okay, that's also a very important question. But again, this is little tricky, by the way. I mean, there is not any straightforward method, or it's not that easy. But yes, somehow it's possible. Though again, that's not 100% accurate. But what you can do, you can dump some random block, basically dump some random blocks from the segment which are in question. For example, in our case, we have got pktr and subscription underscore b. Do some random block dumps and then check uh, the trace with the dump file, basically. And then within that dump, there always you will see the maximum number of attempts that is actually session are trying to increase it, right? Accordingly, if that increases higher or maybe 18, 20, you set that number accordingly, right? But again, you have to do some kind of hit and try method, because unfortunately there is not any direct method available. And even this method is not foolproof or 100% accurate, by the way. But yeah, this is something what we DBAs do most often in order to handle the situation when you have to decide a figure on init trans value. Okay.
Sir, dump means I didn't get properly actually.
Okay. Yeah. Mm, block dump block Oracle. How to dump a block in Oracle? I mean,
That is system
before
dump.
that,
Yeah, that is okay.
before that, if you know the logical structure of a database, like you've got a data file, and data file consists of some segments and extents and everything, right? But at the physical level, DB block is something where you have your data house or residing, right? That is the physical structure, correct?
Yes.
So that has the row information and everything. So what you can do, like you just need to get block specific information for that particular index, which is responsible for frequent ITL allocation wait events, and then dump the block. Like let me show you how. Like for example, DBMS, you actually check, you get the row ID from the table, right? And then convert into the form of a block number, right? So finally, when you got the block number as 134, then you can go and dump the block using alter system dump data file name, the data file of that particular index, and then block number, block 134, right? And
Okay.
then after that, you can go and open that dump file, right? And you'll see all sort of information available there, right? So there are some really good documents available online because discussing dumping a block is something that is little out of scope of this
Yeah,
training,
yeah.
right?
I will go through it. Yeah.
Okay. Let's go back to our AWR report. Okay, so that should be the flow, right? So that is, as I told you, first go with the average number of active sessions, right? And then check the OS statistics. I have a separate slide as well, which I'll be switching in next few minutes now, maybe after 5 or 10 minutes from now, which will also help you to form a strategy, a flow, basically, when you have AWR report and you almost recognize the problem, right? Okay. Uh, so and at the same time, take help of Ash report as well, right? Because AWR is not at all sufficient to provide you details about the wait event I mean SQL ID and wait event relationship and session specific information. It's not present in the AWR, unfortunately. So that's what, right? So whatever wait you are facing, accordingly you have to develop a strategy to handle it, right? Do not go blindly. Okay, this is what I'm seeing, direct path read. Okay, just start your troubleshooting just on the basis of that event what you just saw in the AWR report. You should always go and check the average active average wait times basically for that event, and also its contribution, its share in the DB time percentage. So these two should be the driving force, driving decisions, right? Because never ever go, I mean, okay, this wait event, this has 1 billion of wait events or waits in that particular 15 minutes, so let's start with that one. No, it's not like that. You should always go and check with the average of that particular event. If that average time is less, then you've got something else that has more priority to analyze first, correct? And also check for the DB time contribution, its percentage that's actually contributes to overall DB time. Okay.
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 And apart from that, if you go down, nowadays you also get the Ash reports also embedded into. Unfortunately, I do not see a AWR report here, Ash report here, but usually you'll see Ash reports now clubbed along with the AWR reports. Okay, let me move to the other slide. Uh,
Sir, I have one
yeah,
question.
please
In
ask.
this instance for the index ITL one,
Hmm.
and if that is the case for the table, same method will be applied, or we have
Absolutely,
to.
yes. But there is a difference. Let me show you. Max trans table name.
Because number of time we have seen the ITL has just been invoked for the tables as well. So
Absolutely, as I told you, yeah, it's there on tables too. But now, can you see the difference between an index and a table? The init trans value of an index is always default 2. In the case of a table, it's always set to 1. Okay, yes, you have to do the same thing in a case of a table too. If your table is experiencing or a table is going through a lot of ITL allocation wait events, then you need to dump a block, a table block dump, and then study it and accordingly increase the init trans of it. Okay.
okay.
Too much. Anything? Anything you guys want to ask?